Okay, so in the previous video, we got our stop and our start push button going, and we also got the e-stop to provide a flashing light on this stop button right here. So again, if we hit the start button here, then that turns on our system run. And if you haven't seen the previous videos, this system run will be used to control a large portion of the program below. So nothing will work unless I hit the start. When I hit the start, it turns this guy on. It's a memory bit, and it will then control this light down here. So this instruction right here is looking for a 1. So there's a 1 in the memory, and so my start light is on. And if I hit the stop, then there will be a 0 in the memory. I haven't activated my e-stop, and so my stop light should turn on. Okay, so we got that done, I think, 2 videos ago. And then last video, we got the e-stop. So when we hit the e-stop, we just scroll down here a touch. So we got the e-stop. We had a set and reset for our e-stop activated. You'll see that this is addressed the same, %m0.1 and %m0.1. This instruction here is setting that bit to a 1. This instruction here is setting that bit to a 0. Okay, so if I hit the e-stop will become open. This is looking for an open. That will set my e-stop, and it will do 2 things. It will break logic continuity here, so it'll take out my system run, and in taking out my system run, nothing else will work on my project. And it will also allow this clock bit to flash my light. So once my e-stop is activated, it will flash this clock bit right here, which is already running, and that will hit my stop light, and my stop light will be flashing. So if we hit the stop, we can see that it's just a solid illumination of the stop light. But if I hit the e-stop, then for one thing, I cannot turn on anything else on my control panel. And now I've got a flashing light to tell me that I'm in the e-stop situation. So in this video, we're going to keep going, and we're going to make use of the auto manual switch. So we're going to make use of this guy right here. And we're also going to make use of the reset push button. And those will be all our different settings for our control panel that will then control other things in the program. And we can use those as base instructions on our next, any projects that come up, right? So we've had the stop, the start, the e-stop, then auto manual, and then the reset. All right, let's jump right into it. Let's go back over to our TA portal. Let's go out of the monitoring mode. And what we're going to do is we're going to drop in another network here. So up above, we had our system run instruction. Then the next one we had was our e-stop activated for network 2. And network 3, we're going to call this guy auto manual selector switch. Oh, I can't type today. There we go. Okay, let's put a space here to make it look nice. Okay, so for this guy, we're going to make use of this switch right here. So let's see, let's put the e-stop back so we can stop that flashing. Let's bring up our tags here. And if you missed the previous videos, like go back and watch the other videos, then you'll see all the I/O and everything for this project. There should be a PDF below that shows you all of the I/O that I've used here. So here for the auto manual here, if I go to File and Drivers, I've made use of both of them. So auto goes to input 0.6 and manual goes to input 0.7. Again, if you're low on inputs, it's the same switch. It's not going to be in the same like, it's either going to be in auto or it's going to be in manual, right? So you can use one contact and use opposite instructions, but I just made use of each of the contacts there. So I have one for auto, which is input 0.6, and one for manual there. Okay, let's go back. So right here, you can see that it's in manual mode. And if we find manual mode, that guy's right here. So you can see that it's illuminated. And when I hit the switch here and go to auto, where's my auto? Too bad it's not right beside. It's right here. So you can see that my auto is a 0 right now in the memory. And when I click the switch, it turns to a 1. So as soon as it's illuminated, that means that there's 24 volts going to the PLC. And that would mean that there's a 1 in the memory. Okay. If I go back to manual, so manual is right here. Right now it's a 0. When I switch it over to manual, then this will this will be illuminated, showing that there's 24 volts to the PLC, showing that there's a 1 in the memory. Okay, so you can see the states of all your contacts here by bringing up view and then docking all your tags. Okay, I'm going to clear my dock tags now. So I want to make use of that auto manual switch. So I'm going to start off here. I'm going to grab one of these guys right here. I'm going to grab here. So this one is a normally open, what I call an examine if closed. So I'm examining when that open contact is going to close. I'm going to bring this guy and drop her down until I see green. Okay, and I'm going to double left click on this guy. And I'm just going to start typing in manual. And there it comes up because I've already done all of my inputs and my outputs on a previous video. So I already set them all up, both in the Factory.io and in the TIA portal. So as soon as I type in something close to manual, it brings up input 0.7. Okay, and then I'm going to put an output on the end there. It's not going to be a true output in that it's not going to control anything outside of the PLC. Again, it's just a memory bit that I can make use of later on. So a memory bit is basically used to control other rungs in your ladder, but not really directly controlling anything outside of the PLC. Okay, so I'm going to call this one manual mode. So I haven't made this one up yet. So you can see that nothing came up there. So what I'm going to do is I'm going to say %M0. Let's see, I'm at 0.1 now, so this guy is going to be M0.2. Okay, so you can keep track of all of your memory bits on a separate list, or if you're doing an Excel spreadsheet, you can keep track of all of your memory bits so that you don't have the same memory bit for different portions of your program. So we'll hit enter. And now I'm going to right click on this guy. And I'm going to go to rename tag. And now I can name that memory bit as manual mode. Beautiful. So now anytime that I'm in manual mode, I can make use of this guy and use it to control other portions of my program. Okay. If I scroll down, I'm now going to add another rung. So I'm going to click right here on the left-hand side. I'm going to click this guy right here to add a new rung. And I'm going to do the same thing. In auto, I want another output to turn on. Okay, this guy right here, I'm going to double left click on this guy and start typing in auto. There's my input 0.6 that my auto switch goes to. Okay, I don't have a memory bit set for auto mode, so I'm going to click on this, double left click on this guy and type in %M0, and my next one is .3. Okay, right click on this guy now, rename the tag, and this guy is going to be auto mode. Beautiful. Okay, so that alone is probably good, but we want to put in just a little bit more of a safety. There's obviously the mechanical safety in that it can't be in the same position at the same time. So mechanically, it really can't be in the same position, but let's do an electrical interlock as well in that if it is in the manual mode, I don't want it to be able to go into auto mode. So I'm going to do this. And I'm going to grab this guy, an XIO, and grab her and drop her down until I see green. I'm grabbing the same instruction and dropping her down on my previous ladder there. Okay, and now I just need the opposite instruction here. So for here, I want to say, all right, that if the manual mode has to be a 0 or has to be off, right? So this one is an XIO or examine if off. So, and I have now two manuals, right? So manual as an input and manual as my memory bit. So I'm looking at the memory bit and I'm saying, as long as this is a 0, then allow my auto mode to turn on. Okay, so again, we have the mechanical interlock here between the two positions of the switch. And then we're making it extra safe in that we're putting in electrical interlocks. This is exactly the same as a forward reverse contactor with the electrical interlocks, having the opposing instruction in series with that coil there. So again, we're doing auto mode, and I'm saying as long as the auto mode is off or the auto mode is 0, then allow the manual mode to proceed. Excellent. Okay, let's download this to our PLC. Okay, so I've downloaded it to the PLC now. We'll put it into monitoring mode. Let's bring up our animation here. Excellent. Okay, so now you can see right here that I'm in the auto mode, right? That's where I left the selector switch. So the auto is now a 1. This is looking for a 1. The manual is a 0. So that allows my auto mode to proceed. Okay, if I change the selector switch, then this will be true, this will be true, and the manual mode will turn on. Beautiful. So that's as easy as it is, guys. Now, Some of you guys might have a different way of doing auto manual mode. If you do, then leave it in the comment section below, or send me a PDF of your program, just so we can see different ways of programming. But I find this is the easiest way to go between auto and manual mode. Provides me with a memory bit that I can use throughout my program. And with these electrical interlocks, make sure that I can't be in both modes at the same time. I can only be either in the manual or the auto mode. Beauty. Okay, so now we got our stop, our start, our e-stop. That is still working. Like if I hit the e-stop, all the other portions of the circuit are working. But the next thing I want to do is I want to make use of this reset push button. So if I am in this e-stop mode, I want to hit this reset and reset this push button indicator light right here. That way that I'm kind of acknowledging the fact that I'm in the e-stop mode. I'm resetting it so everything will go back to its base state. And I can make use of that reset button to reset timers and counters and everything later on in the program. All right, so let's work on that now. So let's go back to our TAA portal now. Okay, so let's go back to our TAA portal here. Let's go offline. And the next one we're going to do is our reset. So we'll do network 4, and let's call this one reset instruction. Okay, so obviously we're going to be hitting our reset push button. So we're going to grab this guy right here, an XIC, or a normally open contact. We're going to drag it down till we see green. Okay, and then I'm just going to label this guy a reset. Again, all of my I/O was done previously, so this comes up right here. I want my reset push button for my input 0.3. Okay, and when I hit that, I want to go into reset mode. So I'm going to put an output here at the end. I have not set this reset mode. I'm going to make another memory bit. So I was on %M0.3 for my last one. So this guy is going to be %M0.4. Okay, and then I'm going to right click on this guy, go to rename the tag, and we'll rename this reset mode. Beauty. Again, so anytime we want to reset things in our program, we're going to make use of this memory bit to do that now. So we don't have to worry about this push button anymore. This push button will hit this memory bit, and it will turn this guy on and then control other things within our program. Now, what I want to do is I don't just want to have it just reset for like a split second because mechanically a number of things take quite a bit of time to go back to their rest state. So if you have some actuators and stuff that need to revert back to their rest state, that's going to take a couple seconds for them to physically get back to their home position. So we need to put in some timers here. So for one, we need to make sure that the reset mode stays on. So we're going to put a parallel rung here. And we're going to put another XIC here, or a normally open contact. Let's grab this guy, bring it up till we see green, and drop her in. And let's address this the same as our reset mode. So now when I type in reset, I have a number of things, light, mode, and push button. So once my reset mode has switched from a 0 to a 1, then I want to provide another path of logic. So again, anytime that you want to keep something on, you're going to put a holding contact in parallel with whatever instruction turn that output on. Okay, so again, reset push button will be pressed. That'll turn on our reset mode, %M0.4. That will turn this from a 0 to a 1. We're examining for a 1. And if we let go of this push button, this will maintain our path of logic to keep this guy on. Okay, we are also going to turn on a timer. So we're going to put another rung here, and we'll put an on delay timer. So I don't have that as my my favorites up here. So I'm going to come here and open this guy up and look at my instructions now. Okay, I'm going to timers, and I'm going to grab an on delay timer here. So I'm going to left click here, drag it over until I see green, and drop her in. Okay, for this guy, I can just say I can rename it as my reset timer. There we go. We're going to keep it in automatic mode. Okay, and the preset for this guy, I don't have very many. Like all I'm doing is I'm just resetting that flashing bit for the light at the moment. So I don't have any real actuators that are going back into the rest state. So I'm going to put 3 seconds for the timing here. So we'll hit enter here. Remember that the setup for this guy for the preset is in milliseconds. So you have to type in 3 and then seconds. I don't know if that's going to work because that says, so let's do 3S. Let's get rid of that guy. See if that works. There we go. Okay, so you saw before it had quotations around it. So it's not SEC, it's just 3 and then an S there. Again, if you don't put the S in there, it'll be 3 milliseconds. Okay, this is my estimated time. My Q doesn't actually have to hook up to anything because I'm going to make use of the output up here. So up here in this rung right here, the reason for this timer is that I need this guy to, when I hit the reset push button, that's going to start this on delay timer. And that timer is going to time out for 1, 2, 3 seconds. At the end of that 3 seconds, I want it to disengage this holding contact right here. So I need this guy to be a normally closed contact or an examine if open. So we're going to drop that guy in there. There we go. Okay, for some reason I got 2 of those guys. Let's get rid of this guy. Okay, and I'm going to double click on this guy and I'm going to put reset timer. Okay, so there's my reset timer right there now. And it's going to say, all right, do you want the in or the output? So I want the output being Q, so reset timer.Q. So as long as that timer has not finished timing out, then I can allow my reset mode to happen. Once it actually times out, then the Q will be a 1. This will no longer be true, and that will kick out my reset mode. Okay, let's see if this works here. That's making me a little bit nervous because it doesn't seem like it looks correct. But let's see, let's download it and see if we've made any mistakes here. Okay, so I've downloaded now. I'm going to go into monitoring mode. Let's bring up my factory IO here. Okay, so it looks like we're okay. So that was making me a little bit nervous, and it had the quotations there. It didn't have a percent dB1 or anything, but it looks like we have logic continuity to my reset push button. Obviously, my M0.4 has not set yet, so this is not true yet. And my reset timer is a 0 at the moment. So the Q is a 0, so this is true. So if I hit this reset push button, then that should allow continuity to go to M0.4. So let's do that. And we should see that this guy times out for 3 seconds and then kicks out the reset mode. Okay, so let's do that now. So it's counting up 2. Beautiful. And then after 3, it was able to kick that out. So I like this way of doing it. I learned this from Robert Parker. I'll put a link to his videos below. When you hit this reset push button, instead of just like setting and then resetting a reset mode, the timer does it for you. So it allows you for 3 seconds to reset everything, and then it kicks itself out. So again, once the timer goes to a 1, this is no longer true, which will break that logic continuity. So again, we'll hit the reset button again. You can see that it resets for 3 seconds. And once it's done the 3 seconds, then it kicks itself out. Beautiful. Okay, let's go back to our TAA portal because we've got this reset mode set up, but it's not controlling anything else in our program. So there's a number of ways you can make use of that reset. It's just up to you how you want to implement it into your program. What I want to do is I want to reset everything so that when I hit this push button, then it's going to stop this light from flashing. So what I want to do is I want to put it in 2 positions here. So the one position that I have my reset, and again, my reset mode is %M0.4. And so that guy, I don't want to be able to reset my e-stop until I've acknowledged that and reset my program. So I'm going to put a normally open contact here, and that's going to correspond to %M0.4. Okay, so not only do I need to put it back into my e-stop, back into its rest state, but I also have to acknowledge the fact that I wasn't in e-stop and hit the reset mode. And this will time out for 3 seconds, which will make this true, which will then revert my e-stop back to its rest state, okay, or back to a 0. The other thing I don't want to do is I don't want anything else working in my program while I'm resetting everything. So I'm going to use an examine if open. or a normally closed switch. And I'm going to say, because this looks for a 0, right? Or something that is off. So as long as I have not initiated my reset mode, then I can allow my system run to work now. Okay, so I put it in 2 places now. So let's download this and see how this affects our program now. Okay, so I've downloaded it now. I'm now going to put it into monitor mode once again. Bring up my simulation here. Okay, so you can see now that my e-stop has been activated and my light is flashing here. And normally if I just reverted this guy back to its rest state, then this light would go solid red. So let's do that. Let's revert the e-stop back to its normal state. Okay, you can see now that the light is still flashing. So if I scroll down here a touch, you can see here that my reset mode is stopping me from resetting M0.1 for my e-stop being activated. Okay, so not only do I need to revert the e-stop back to its rest state, I also need to press the reset, and in doing so, then this will become a solid red. Beautiful. That reset's going to go for 3 seconds, and then after those 3 seconds, I'll be able to, if we just scroll up here again, now I'll be able to hit the start push button. I got green right across, and now everything's going to work properly now. Beautiful. Okay, so everything works great. We've got our start, we've got our stop, we have our auto manual. So if I scroll down here, nothing that we just did affected the auto manual. So here you can see the auto manual and switching back and forth. So the reset has nothing to do with this portion of the program. So we have a stop, a start, we have auto manual. We now have an e-stop button that now kicks out our system run. So you'll see that as soon as I activate the e-stop, it will kick out this system run. There we go. I'm not able to run anything while I'm in the e-stop mode. I have a flashing light to tell me that I'm in the e-stop mode. And in order for this guy to go back to solid red and allow me to run my program again, I need to revert my e-stop back to its rest state. And I also need to activate this timer right here for my reset. That will then allow me to reset this set bit right here. Because it's set right now, I need to reset it. And the only thing that's going to do that is the reset mode. So we'll do that. Hit our reset. It runs for 3 seconds. Okay, and then kicks out. That has reset my e-stop, reverted this back to a solid red. And now if I go to my stop now I can run my system run. Beautiful. All right, guys, hopefully that helped you out with this project and with future projects, because we can use the same thing, right? We can literally just save this as a base program now if we're using a stop, a start, a reset, and an e-stop. Again, the reset, in this case, I've used to reset this one, but later on, you can maybe, if you're doing things where you're doing a pick and place or something, and you want to revert all of your actuators back to their rest state, then you can make use of this reset button, which is now controlling that memory bit. That memory bit's going to run for a couple seconds and allow each of those actuators to mechanically go back to their home state before you can revert back and start your program again. All right, guys. Again, if you have other ways of doing this, or if you feel you have better ways to do this, then leave your ideas in the comment section below. Email me PDFs of your programs and show me different ways to program so that we can each learn from each other. All right, guys, hopefully you've enjoyed this video. I'll see you on the next one. The next one, we're finally going to get to the move function that I talked about earlier. So keep going in the playlist, and the next thing we're going to do is control the levels in the tank. We now need to do our manual mode. So next one is going to be manual fill and manually draining the tank. All right, guys, see you in the next video.